Welcome everybody to our Lunch and Learn. Our Lunch and Learn today is Friends of the Rappahannock with Nancy Stalik, who is their education director. And I'm Lee Criscolo. I'm the head of adult services at the Howell branch of the Central Rappahannock Regional Library. So Nancy is going to teach us about what the Friends of the Rappahannock does. Mute that. And we'll just get right to the presentation.
Thank you, Lee. I'm really happy to be here today. So what I'm going to do today, this presentation is one of the stock presentations that we bring to students in the area, and it's on water quality and what are the things that we do that affect the water quality and how we can tell what the water quality is in our area. So the first thing we like, and this is usually for students in 4th, 6th, and 9th grade. We do these for kids all over. In fact, in our Fredericksburg office, we see over 8,500 kids per season. And that is just in our Fredericksburg office. What we normally ask the kids to do is to ask how their daily actions affect the health of the river. They usually don't get it at first, but just know virtually everything you do affects the health of the river. We work within the Rappahannock River watershed. We care about water everywhere. We tell this to the kids too. We care about water everywhere, but we can have the most effect on the waterways that are closest to us. So at Friends of the Rappahannock, we kind of focus on the facts for the Rappahannock River, and the Rappahannock River does empty into the Chesapeake Bay. But those facts that I'm going to give you about waterways and watersheds, they pretty much have to do with watersheds all over the world. First of all, what is a watershed? We ask this to the kids, and in the kids that are in the grades of 4th, 6th, and 9th, they are studying that. So they usually come up with a big amalgam of what that is. Sometimes they get a little confused and they think it's a shed with water in the backyard. Maybe sometimes, but we're referring to an area of land that channels rainfall and snowmelt to a common outlet, such as a river, lake, or ocean. I happen to live in a very hilly neighborhood. I am the first flat lot. So in a micro environment, I have a watershed in my backyard because everyone's lot above me drains into my yard, and my yard is flat. I will, if I remember, I will tell you what I did to fix that, but I used to have a river that ran through the back of my yard along a fence because I am the watershed for the whole, my whole street. So that's what a watershed is. In the Chesapeake Bay watershed, there's 5 rivers that empty into it. For the Virginia SOLs, they have the kids only learn the 4 rivers that are from the state of Virginia. But the big watershed that you can see that comes down from the K and the S, the K in Chesapeake and the S in watershed, that's the Susquehanna. That's actually the biggest river. But the other 4 rivers from north to south that empty into the Chesapeake Bay from Virginia are Potomac, Rappahannock, York, and James. It's a hugely densely populated area, of course. So what we do on the land affects the water. So this area is affected very much by human population because there's so many of us. Over 18.3 million people call this Chesapeake Bay watershed our home. It's also the largest estuary in the United States, which means it's very important because estuary areas are where a lot of the life that lives in our waterways gets their start, in those nutrient-rich brackish waters that lead into bays. So we do always ask the kids if they know what states are part of the watershed. It's already on your slide there, but kind of quiz yourself. It's an extensive area. It includes the District of Columbia, New York, Delaware, Maryland, Pennsylvania, West Virginia, and Virginia, parts of all those states. This kind of shows you a better show of the watershed and where the watershed's from. So underneath is the layer of states and the state boundaries. And then over the top, superimposed, are those specific watersheds watershed areas from the different given rivers. And again, with the SOLs, we're concentrating on what the teachers want to teach. We teach the 4 rivers of Virginia. So even though you're seeing Eastern Shore and Patuxent, we focus on Potomac, Rappahannock, York, and James. And the Rappahannock is the watershed there that's in the red. Here's another show of all of the watersheds in Virginia, just to kind of give that bit of overview. Again, with all the states, and then that's just Virginia, because we have to focus a lot on Virginia. This slide is showing the watershed of the Rappahannock River specifically. So if you look at the outline in green, those are actually all high points. Watersheds are all an area where there's a high point around it, so that within that area, if snow melts or rain falls, it will drain towards one side or other of the high point. Anything that drains inside the green drains towards the Rappahannock River, and that's why it's called the Rappahannock River watershed. Outside those green boundaries would be one of the other watersheds on the screen that I showed you previously. The other thing this slide is showing that's very important is the 2 regions that comprise the Rappahannock watershed, which is the coastal plain, closer to the coast, and I'm going to have some pictures of that, and then the Piedmont, which is closer to the mountains. Where I-95, if you can see it on the slide, where I-95, the red line, runs through Fredericksburg, that is the fall line. And the fall line of every river, not just the Rappahannock River, but the fall line of every river is where the coastal plain meets the Piedmont. And that's a very important area because it's at that point where the one-way river in the Piedmont comes to the fall line and starts becoming a 2-way river, which is tidal. That happens in Fredericksburg. I'm presuming most of the people that will watch this live in Fredericksburg and are familiar with Old Mill Park. The water comes down, it gets to Old Mill Park, right around Falmouth Bridge. That's where we go from the one-way river to a 2-way river. That's where we start getting tidal influx on the Rappahannock River. As you go around Old Mill Park and closer to City Dock, that is definitely a 2-way tidal river, and you're now in the coastal plain. The thing that happens when the 2 plains meet, the Piedmont and the coastal plain, when the 2 regions meet, is an area that's full of rapids because those regions erode at different rates. The coastal plain is a softer sediment, it erodes away, and the Piedmont is a rockier sediment. So that's why we have all along Fredericksburg above Falmouth Bridge, we have all the rocky areas that are very exciting rapids to go through, to kayak and tube through, because that is the fall line. That is exactly what a fall line is. The other really interesting thing about fall lines is as explorers and Native people were using the river, boats can only get as far as the fall line successfully, the larger boats that would be used for transport. So that's where all big rivers on coasts are built. Fredericksburg was a very big river. Then once a large significant town is built there on the fall line, that happens all along the coast. That's where they put I-95. First it was Route 1 and then 95. So you can follow 95 up and down the coast. You will find the fall line and a big city. Kind of a very interesting little fact there. And then you can see in the legend over it, kind of shows you what the land is used for within the watershed. 36% agriculture, 6% developed land, and 21% forested land, more or less. And again, how the land is used determines the quality of the water. This slide shows the basic ingredients of the river in that area. The upper watershed, again, that's going to be one-way river. That means it's fresh water. And there's a lot of waterfalls, and that's what predominates the upper watershed. In the middle, this is Fredericksburg. Those rapids, if you go over 95, you are familiar of looking at those rapids. Fredericksburg is the biggest city on the Rappahannock River. And as such, one of the things it gets that interjects into the water is runoff from roads. A lot of people don't know, but all of our storm drains in the Fredericksburg area, and most always everywhere, the water that's collected from storm drains goes directly into rivers without any filtering or screening at all. So that, of course, would affect Fredericksburg because basically all of the flat surfaces in Fredericksburg are cleaned off with rain and pumped right into just flow right into the Rappahannock River, right here. And then the last third of our slide shows the lower Rappahannock. This is fully tidal area. And the farther down you go, you get into more saltier and saltier environment in the water until you get to the Chesapeake Bay. So this is brackish water. There's a lot of agriculture down here, both on land and aquaculture in the water. A little bit about FOR, just for the next part of the slide. Our mission statement is to be the voice and active force for a healthy and scenic river. And we do that a lot of ways. I'm in the education department, so I'm pretty much focusing on what we teach, both to children and adults that we have programs for. We've been around for 40 years, since 1985. Our mission, again, to be the voice and active force for a healthy and scenic river. And we achieve this through 3 main ways. And we have 3 offices now. Our first one was in Fredericksburg. Our second one we opened in Rappahannock. And our third one we opened during COVID in Culpeper. Across the watershed, we serve, I think it's 16,000 kids. And that's just with our education. We have 3 major pillars at Friends of the Rappahannock: advocacy, which advocates for the health of the river, both at the local level, the local government area, the state level, and the federal level. We work with the General Assembly, all of our representatives. So we're primarily focused on things that affect the river. So the big things now are, of course, data centers, and fracking was big a little bit ago. So we're always trying to advocate for the health of the river, and we try to pick a line that allows the river to be healthy, while also allowing work to happen, right? The other part of us is restoration. And in the upper Rappahannock River, we do a lot of tree planting, because planting trees is a huge way to improve the health of the river. On this slide here that says restoration on it, all those little tubes are tree tubes protecting newly planted saplings. So this area, which I presume probably was a farm, they are restoring the area to a treed area along where that little waterway is, which will improve the waterway. And then my department is education. We do education in classrooms and also in our field trip program, which is very big in the Fredericksburg area. Okay, so why do we do these things that we do? Advocacy, restoration, and education. We do it because we love these little guys. These are little river otters. They live all along the river. We love these. Unfortunately for oysters, these are very tasty. And we are a big producer of oysters here in the Rappahannock River. We love tubing. Tubing is super fun. We do this with all our summer camp kids. And I still go with my grown kids when they come and visit. It's a lot of fun. We do it because we love all of the animals. And this eagle is a top predator. So a healthy river means he can live, because the little macroinvertebrates, the tiny bugs that live in the water, which I'll show you in a bit, are eaten by bigger bugs and little fish, and then bigger fish, and eventually eagles and top predators. And if the river was not clean, they wouldn't have food. Top predators wouldn't have food, and the ecosystem would not be healthy. Here's another type of top predator. Here we go, fly fishing. And we love kayaking in the river. These people are canoeing. At Friends of the Rappahannock, we take a lot of kids kayaking. It's one of our most favorite things to do. Okay, so that's why we do what we do. And now I want to bring you into more like the actual things that we measure for water quality. The two leading issues in the Rappahannock River, usually we quiz the kids right about here. So start thinking about what you think the two major issues are in the Rappahannock River, because I'm going to show you, are sediment and nutrients. So sediment or dirt is the number one pollutant in the river, the number one pollutant. It's not supposed to have dirt like you see in there. And then these are not pictures of the Rappahannock River. These are to show the point, to get the point across. And the number two pollutant is nutrients, extra nutrients. So it's good to have nutrients in the river, a certain amount, but we don't want a large amount that causes algae. So if there's a farm that for some reason is letting the fertilizer flow into the water, that would cause a problem for the river. Let me just check on my slides. Okay, so now I'm going to talk about what issues these cause and what it causes in the river. So the reason why sediment is a problem in the river is because that amount of turbidity that you see in that water, and we've all gone over the Rappahannock River if you live in this area after it has rained, it looks like chocolate milk and not just a stream like this is showing. There's probably been a clear cut upriver to where this picture was shown, and a whole little landslide happened. But in the Rappahannock River, the whole thing looks like chocolate milk after like a whole day of very steady rain. That's because it's churning up water, and the runoff from the land is being pulled into the river. If that stayed like that for too long, there's something very important that can't get down through the river. And again, this is where I quiz the kids. So start thinking, what can't get down through the river if it looks like this all the time? And the answer is light. Light can't get down through the waterway when there's this much turbidity, as you see here, or as we see in the river after a day of rain. That is a problem because there's an organism that uses light to make its own food, and that is plants, right? That happens on land. Plants take in sunlight, they photosynthesize, which helps them make food for themselves, and they give off oxygen. That's a great thing for all of us land living oxygen breathers. Well, the water living oxygen breathers also want the oxygen from the plants in the water, and they can't get it if sunlight can't get to them. The long end process of a river that's completely always filled with sediment is what's called eutrophication. It's a long process, but it basically means death of everything in the river. So sediment is one thing we're always trying to focus. Planting trees along waterways, or even better, not cutting them down, is one of the best things we can do to prevent erosion of banks. And then nutrients is, so after that, if the plants are not producing oxygen, that means the oxygen level in the river is low. That's bad for everything that needs oxygen, which is basically everything in the river. The number two pollutant is nutrients, and that's extra nutrients. So that's like fertilizer runoff. That could be chemical or manure, or lots of dog poop, too much goose poop, a septic system sewage seepage, those type of things. Those are called extra nutrients. If they're used on land appropriately, that's fine. But if it's drained into the river, that's not fine because it produces thick mats of algae blooms. We've all heard of algae blooms. So algae blooms do two things. First, if you have this much algae, the sunlight's not going to get through it. So that's the same as sediment. And the second thing is algae is a plant that it has a short life cycle. It dies very quickly. When it dies and decomposes, the process of decomposition sucks oxygen out of the water. So these two pollutants, the top two pollutants, lead to very low levels of oxygen in the water, which eventually would kill everything. And this slide shows you what it causes. It causes dead zones. So this is a picture of the Rappahannock River. The green is the river that has plenty of oxygen. The gray, by the way, is land. Okay. The yellow is areas of the river that has questionable amounts of oxygen, and the red is an actual dead zone. There is so little oxygen in the red portions that nothing can live there. We have that in the lower Rappahannock. We have a dead zone that gets bigger every summer. It gets bigger every summer because warm water holds less oxygen. So the dead zone in the lower Rappahannock River gets bigger in the summer and shrinks a little bit in the winter. Okay. There's also a very big dead zone in the Chesapeake Bay because of the dead zone water that runs into the bay from all the rivers that feed it. So we're trying to prevent dead zones. If a little fish swims into a dead zone, it can usually make its way out before anything tragic happens. But a big fish, like a big gar, if you go down boating in the lower Rappahannock, you'll see those belly up. That's because they got into a dead zone and they could not swim out. And some things can't move, right? Oysters can't move. Clams can't move. If the dead zone expands and they're in it, they die. They can't do anything about it. So we're trying to avoid the dead zones. We want highest oxygen as possible. So the way we test for that is we do biological and chemical testing. We teach kids that all the time. But while these are very simple ways, this is what is done all over Virginia, all over our country, all over the world to determine the health of a river. Okay, biological testing and chemical testing. I'm going to tell you a little bit about what we do. For chemical testing, we're testing things like the pH, which is the acidity of water, the nitrates, which is testing how much extra nutrients, phosphates, testing how much nutrients, and dissolved oxygen. Okay, so for pH, and we have the kids go through all of this. We have a sample of, I don't know, like water from the tap, and then we're usually doing these right near the water, so we get our samples right from the Rappahannock River, and the kids test them with all their test kits. So pH, we want that in the medium range. pH ranges from 1 to 14. We want like the 6 to 8 range. And we usually always find that in the Rappahannock River. Nitrates and phosphates, those are extra nutrients. We don't want to find those. And we don't in the Rappahannock River where we test. And dissolved oxygen, we want that as high as possible. We want that as high as possible. So it's a little higher in the winter months, a little lower in the summer. That does happen naturally. Pretty much in the winter, I get like 8 parts per million, and in the summer, a little less than that. But we like to tell the kids we need 5 parts per million to stay alive, 5 to stay alive. Anything less, and the water can hold less, a less diverse population and a lesser number of individuals. So we test dissolved oxygen and temperature. There's a relation to that. Again, as I told you, warmer water cannot hold as much oxygen. So we do not worry in the summer when we see the dissolved oxygen lower a little bit. That is natural. And then, okay, I told you about the pH. And then turbidity. Turbidity is the cloudiness of the water. Obviously, we want as low cloudiness as possible. And when the Rappahannock River has not just had a rain, we can see through 120 centimeters of water using what we call a turbidity tube. We also have a little probeware that measures it in NTUs. So it runs a laser through, and we pretty much get like the little vial you see here with the 10, perfectly clear. And with the turbidity tube, we're building our own column of water in a long tube, and we look down the bottom to see if we can see this little checkered black and white square, which we always can if it hasn't just rained. This is very good. The water's very clear unless it has rained. That's what we want. Again, these are some slides we use for students, so just to show you that. The other thing we do with students is biological testing, and that's looking for the little bugs that live in the water naturally. In our area, we use what's called a kick net, which is a 1 by 1 meter net. We stand in the water. One of us hold each side of the kick net, and somebody stands in front of the net, kicks around in the rocks. Of course, if you're doing this for official government data, you have to follow very specific protocols, which we tell the kids about. But when we go to do it, we don't have as much time as it takes to do that. So we just get a sample and let the kids experience what that's like, what that whole process is like, and why we do it. What we're looking for is macroinvertebrates, and we put them into categories when we ID them with the students. We're looking for tolerant species. If you have nothing but tolerant species, so think of a leech. If all we found were leeches, those are very tolerant species. That would not be good for the water. That means nothing else can live because the water has such poor quality. If we find very sensitive species, like the nymphs of dragonflies, those are very sensitive. If we find those, we're like, hey, this water's pretty good because this organism needs healthy water. If we find all the healthy stuff and a leech or two, we're fine. That's just diversity. We would only be in trouble if all we found were leeches. So we get our sample of macroinvertebrates, again, the little bugs that live in the river. We ID them, we kind of put them in categories, and we see how much of each we have. That's the basics. Here's just a little dichotomous key. So again, the students use the use of a dichotomous key with us, and we really do ID all these individuals and put them into sensitive and non-sensitive categories here, as you see. There's a little rubric we can do to get to a final number. So in this presentation, you have learned about what a watershed is. You have learned about the different areas of the Rappahannock River. You have learned the top 2 pollutants of the Rappahannock River, which I hope you still have in your brain. That is sediment and nutrients, what they cause if there's too much, which is a dead zone that's larger. We want to keep that small as possible. And you've learned the 2 major ways we test for the health of the river, which is chemical and biological water quality testing. So just know there's a lot of things you can do to help keep the river clean. Litter pickups are great. And also just keep your use of water to a small standard, try to be sensible with what you're doing. If you had a little stream in your backyard like I did, I encourage you to plant trees. I was able to get my hands on some trees that we plant at work, and I was able to plant them in my backyard. I no longer have a little stream back there because planting trees and plants and other shrubbery on a waterway, the roots of the plants help keep the water where it belongs. So thank you very much for listening, and I hope you learned something new about your watershed today.
Thank you so much, Nancy. It's Nancy Stalik, Education Director for the Friends of the Rappahannock. If you want to learn more or get involved, you can visit the Friends of the Rappahannock website, which is up on the screen right there. A lot of really good information about the Rappahannock. Thank you so much.
Thank you for having me.
See you next time.